Here it is again. Okay, so now plane mirrors. My students used to get really confused about this. Like, what is a plane mirror? It's just a regular flat mirror, like the kind you have in your bathroom. Okay. So what's nice about a plane mirror is sometimes these curved mirrors that we're going to talk about, they have like weird looking images and you have to kind of memorize stuff to, know which is which, what kind of, but with a plane mirror, right, this is the kind we look in every single day, so right? For example, um, when you look in a flat mirror, is your image upside down? No, right? It's right side up, right? Sometimes the textbooks and stuff will call it upright, but right side up is fine. Um, right? Can you imagine trying to brush your hair or brush your teeth or something, put on your makeup, if your image in the mirror was upside down, right? That would be really hard to do. Um, so if this was our mirror, and we in physics we like to use arrows as our objects because we're not good artists, and so our so this is our object. That would be like you or your cat or your dog or whoever's looking in the mirror. And this would be the image. Okay. Um, the image type, we've got two types of images. We have real images and we have virtual images. We're going to get into probably next time the actual like nitty gritty about what makes a real image and what makes a virtual image. But one of the things that I use sometimes to remember is that like this is real life, right? That's where you are. And this is virtual land. So if your image was in virtual land, it's a virtual image. If your image shows up over here, it's a real image. Okay, which is kind of a weird way to think about it, but so anyway, this is a virtual image. And then your image height. It's going to be exactly the same, right? Your image in the mirror is not like way taller than you or way smaller than you in a regular flat mirror, right? It looks exactly like you. It's just, flipped. Okay. And so that's what we call our this is what am I trying to say? For this module, this optics module, you're going to do a lot of describing the image. What type is it? What height? What orientation? Is it upside down? Is it right side up? Is it bigger? Is it smaller? Is it virtual? Is it real? A lot of the questions are going to ask those types of, they're going to ask you to make those kinds of descriptions for your answers. Okay. So these are the formulas we're going to use for this unit. You could use them for plane mirrors, but you don't really need to because, we already know they're exactly the same. Okay, and personally, I absolutely hate these formulas because they have fractions. I don't like doing fractions. I don't know where it comes from. I just don't like it. Okay, so the first thing I'm going to do, let's say I have 1 over 5 equals 1 over 3 plus 1 over di. First thing I'm going to do is go ahead and convert this to a decimal because I hate fractions. Okay, I'm not going to try and do least common denominators or any of that stuff. I'm just going to go straight to this. Okay, and then then I can do, and then, whatever that number is, 1 over di, and, go from there. Okay, multiply both sides by di or whatever. Okay, so the first thing I'm going to do is I'm going to put these numbers in and I'm going to turn to a decimal, and you'll see when we start doing the math. That's how I do it. Sometimes the video or the book will want you to, I know you guys don't have a book, but will want you to do these. Keep it in fractions I don't do it. It's too hard. It's too difficult. I'm all about making my life easier, so I'm going to go straight to the decimals. Okay. This one, usually you know 3 out of 4, so you can do that. When I was in school, they called it peanut math, but I think it's cross multiplying or whatever they call it. But you'll need these formulas on your test, and you'll need them this unit. You'll probably end up accidentally memorizing them because you'll use them so much doing practice problems. Okay, the F stands for the focal length of your mirror or your lens, which we'll get to. You'll see what that means. Your DO is your object distance, O for object. Your DI is your image distance, I for image. Your HO is your object height, O for object. And your HI is your image height, I for image. Okay, so these are the formulas that you're going to use in this unit. It's really important that you know them. And it's important that you know what these things are. I was surprised, like in the face-to-face classroom, like it'd be like the day before the test and someone would go, "What is DI?" Oh, great. We've got a lot to do before tomorrow. You know, you need to know DI before tomorrow at least. So then we're gonna start doing these curved mirrors. We're gonna work through the different diagrams in a second, but I wanted to make this chart for you guys, and it basically for your math. So like when you're doing the math and it says if you have a convex mirror and it says your focal length is 5 centimeters, in your formula you're going to write -5. Okay, and you have to do that, otherwise your math for your convex mirror is not going to turn out right. It's going to turn out like a concave. Okay, so it's important that you've got these right. If your object is put in front of the mirror, which most objects are, because it doesn't really make sense to put your object behind the mirror, then it's going to be a positive object distance. Okay. If your object is upright, which most of your objects are upright, it'll be positive. But let's say you get a -3 centimeters for your height. Okay, and it says, is your image upright or inverted? Okay, well, if you get a -3 for your image height, that's telling you that your image is inverted. Okay, so you can answer some of these types of questions, um, with the math that's telling you something. If you get a DI that's positive, then that's telling you that you've got a real image. Okay, so you can kind of figure that stuff out when you're doing the math. It kind of helps you. If you kind of know what's plus and what's minus. I like to memorize this. Every year I have to rememorize it because I've forgotten it. But I like to memorize it. So this is a concave mirror. And the way I like to remember it, it's totally stupid, but concave mirror and concave lens have this, like, it kind of goes in. So I think of it as making a little cave. And so that's how I remember concave and convex. I'm not even kidding. Concave is the one that makes like a little cave. Like a little person could hide in here. And then convex is the other one. Okay, and this is what it looks like. This curved line is your mirror. This F is called your focal point. And you'll have that in a lens too. This C is called your center of curvature. And basically, if your lens or your mirror were to make a big circle, this would be the very center of that circle. Okay, so if your lens made a circle, or your mirror made a circle, that would be your very center, and this would be like your radius. Okay. Now, let me see. I'm gonna do some color. this distance here from your focal length to the center of your mirror, which really it should be down here. See, I can't get it to work there, but anyway, that distance is called your focal length. Okay. And so when they say that a mirror or a lens has a focal length of, that's what they're talking about. The distance between that F and basically the distance between these 2 points. Okay. Let me do another color. It's red. Okay. Okay, now this distance, the distance from your object, that arrow is your object, from your object to the center. You see where this red is? Okay, that's called your object distance. That's your DO. Okay, this is your object. Okay, now I'm going to get another color. Let's do green. Okay, now this, from the top of your arrow, should be the top of your arrow. I know this went a little higher, but it's really just the top of your arrow. That's your object height. Okay, and then let's say our image was, let's just say our image was right here. I'm just putting it here because, you know, we're kind of filling up over here. Let me see. Let's do maybe this purple. Okay. So the distance between your image and the center right here, it's not really showing up very well. That's going to be your image distance. Sorry, I had a coughing fit, so I wanted to go ahead and turn off my mic for you guys. Now this is going to be your image height. Oh, I called that DI. I was coughing. Oh yeah, that is DI. That's your image distance, and then this is your HI. Okay. So the distance between F and the center of the mirror, that's your focal length. The distance between your object and the center of the mirror is your object distance. The height of your object is your object height. The distance between your image and your mirror is going to be your image distance, and then the height of your image is going to be HI. The C stands for center of curvature, and the F stands for focal point. Now, for example, this would be a negative HI because it's upside down. Okay. Now, let's go ahead and let's try and draw a picture. Now, for these drawings, you're going to have a couple different, I'm going to do them in different colors. When I did this in the face-to-face classroom, or when I draw them on paper, I like to use a couple different colors of pen. So the first thing we're going to do for this one, and this is closer than F, is we're going to be at the top of our, I want to make sure I do it right. So I'm going to do it a couple times until I can get, okay, that's probably as good as I'm going to get. You want it at the very top of your arrow. And then you want to go through your F, and you want to intersect through this. Okay. So you've got one where you're going parallel to the top of your arrow till you hit the mirror. And then you're going to go through your focal point till you hit that line and go all the way up. Okay. And that's your first one. And then what we're going to do is we're going to have a bunch of lines and they're all going to intersect. And that's going to be where our image is. Okay. And where they intersect is the top of our image. Okay. So now we have another one where we're going to go through. Let me see. I'm not at the right angle. We're going to go through the center of curvature. We're going to hit the top of our arrow. And we're going to go through. Okay. Wait a second. I was like, something is not right here. This green one, I drew this green one wrong, and I'm really sorry. I'm thinking about a lens instead of a mirror, so I'm going to go back and fix that one. Okay. So I'm going to be at the top of my arrow, and then I'm going to go through my focal point, and it's going to hit it like this. Okay, with a lens, you would hit it on the other side. And so I was thinking lenses. Okay, now with our center of curvature, we're going to go through our center of curvature, we're going to hit our arrow, and we're going to go here. Okay, and so that's our our second line. And then we can actually even do one more. Okay, and this one more, you really only need two, right? But we go ahead and we'll do a third just so you can see all of them, and then you can decide which two that you want to do. Okay, so we're going to do one where we're going to go from our focal point. Let's see, that's not going to go exactly right. This is actually easier on paper than it is on the computer. So pretend that's going through the focal point, even though it's not, as well as I would like it to. And we're going to go through the focal point, we're going to hit our arrow, and then we're going to hit the mirror. Okay, and then we're going to go horizontal. And you see why this is kind of important to have them all in the right spot, or they're not going to intersect correctly. So I'm going to fix that red one. Okay. So this should be, if I had done mine right, it would hit, it would hit in this spot. It's supposed to be parallel. I'm going to pretend that this is parallel. And then that is where your image is going to be. So your image is going to be where all three of those lines intersect. So for this one, we'll have something like this. Okay, and your the tip of your arrow is where they intersect. I would have some students, and they would draw this. I'll show you. They would draw like kind of like this. I'm like, okay, that's nice, but where is the top of your arrow? Where's the top of your image? Is it right side up or upside down? If you just have like a line there, we don't know if it's upside down or right side up. Okay. So you've got to make the arrow. Okay. So there's our image. And so now if we wanted to talk about this image, okay, we could say that it's upright, right? It's not upside down. We could say that it is this is going to be I want to say it's a real image. I'm going to make sure that I'm telling you the right thing. Virtual. So I wrote virtual. I was getting ready to write a V, and then I was like, wait, maybe that's not right. I shouldn't second guess myself. I, I've taught myself that for tests, but so we've got upright, it's virtual, it's going to be larger, right? Larger than the object. And then I think that's all we really need to say about it. Okay. But do you see, like, once we've drawn our picture, we can kind of write these things about it. Okay. Now let's do at F. So at F, do you see how here we had to make our drawings go through F like that and touch our object? Well, we can't do that here because our object is on F. So at F, you're going to get no image. It just doesn't work. Okay, so there's nothing you can do there. Okay, now between F and C. Okay, so I'm going to draw, we're going to do our 3 different lines again. I'm going to do my green one first again. So I'm going to go from the top of my arrow. Uh-oh, I've got this big arrow. I just want a straight line. Okay, so I'm going to go parallel from the top of my object, and then I'm going to go through the focal point like this. Okay, see how that one didn't work that well? I'm going to keep doing it until I get it right. That one's pretty close. Okay. Then I'm going to do the next one. Remember that one that goes through the center of curvature? Okay, it's going to go through the center of curvature, and it's going to hit the top of our image. Okay, so it's basically, you want it to kind of go up here. Just pretend that it's hitting the top, because this isn't very exact. Okay, and then we'll do one more. Okay, so we're going to go from our object through the focal point, and then we're going to go horizontal. Okay, that one didn't work very well at all. I think because all of my lines are a little bit off, I think that's why they're not working. You see how this one's like a little high, and that one's a little off. I really prefer to do these with pencil because then I can do them really exact. But at least this is showing you that if you don't do them very exact, they're not going to work out very well. Okay, because you want this one to be parallel. Okay, so like if this one had been right on this thing and that one had been right on it, and these have been, they would have hit. But anyway, because these two are right, this one's just not working out quite right. But basically, you're going to have a line that's going to go horizontal from it, and then and then angled through the focal point, and then you'll have another one that's angled through the focal point and then horizontal. So they're kind of reverse of each other. Then you're going to have your image. That was really far off. You want it to be straight, but anyway, this is the best I could do with this software, I guess. And so then we've got our image. Okay, so what can we say about our image? Well, if the other one, you remember the image was over here before and it was a virtual image? Since this one's over here, right, in real life land, it's going to be a real image. And then we know that it's inverted, right? You can also say upside down. and it's larger. Once you guys are doing these on your own paper, you'll kind of see um, how they work really well. I really, really, really like to use a ruler with these. As you've noticed, I'm still trying to use this line tool instead of drawing it freehand because I want them to be really straight. At this point, I'm thinking maybe freehand might be just as good. But anyway, so that's between F and C. And so there's like 3 or 4 different cases, and basically you need to know each case. You either need to know how to, if it asks you about it, you can do a couple things. You can memorize it, right? That's some people, it's easy for them to memorize what happens with each one, what the image looks like on each one. Like for between F and C, you can memorize that the image is real, inverted, and larger. Okay. For me, I would rather remember how to draw the images, and then if I need to, I can, if they ask me a question about it, I can draw an image real quick or draw the diagram real quick and kind of figure it out on my own. So I'm going to take this one and I'm going to go, well, that's not what I wanted. Okay, I'm going to draw my horizontal from my arrow. One. Excuse me. And then that goes through the focal point. You see how I'm not quite through the center of the focal point? Let me see if I can get it a little better. Because I would really like the images to work out, and it's a little better. So we've got that. And then we have that. Oh, hey, Caroline. How long have you been here? I'm just like totally talking to myself. So, I'm basically reviewing for the optics unit because you guys are going to kind of start that next week. And so what I'm going to do is I'm going to go ahead and finish this review, and then I'll answer your questions after if that's okay. Unless you don't have time. Okay. Yeah, yeah. No, it's totally okay. I just looked over and was like, hey, Caroline's here. So basically, I'm drawing like curved mirror diagrams. They're really, you gotta be really tedious with them. You gotta be really careful. And so this tool that I'm using is a little off, and so my diagrams aren't coming out exactly perfect. But you know, when you start doing them, you'll kind of see what they're supposed to look like. So the first line we draw, or the first set, is a horizontal one from the top of our object. That's what this little arrow is, to the mirror. And then we'll do one that's going to go straight through the focal point and hit that line as it hits the mirror. And then we'll have this like longer line like that. The next one is going to go straight from the top of our, see, I have to start kind of lower. This tool just isn't as exact as I would like it to be. We'll go with that. And you're going to go through the focal point, or the center of curvature. That's what that guy's called. Excuse me. I have a cold today, so I'm coughing. I know it's annoying in your headset. And then where these meet is basically where your image is. I'm going to try and draw the third one, but I haven't had much luck because this software's kind of not as exact as I'd like it to be, and so I'm having trouble getting them to kind of line up the way I want them to. So you'll draw the last one, and you really only need 2 out of the 3. So you could do the center of curvature and the green lines if you wanted and skip the red one altogether. But I'm doing all 3 just to kind of show you what they should be. And then, so the last one is angled from the top of your object through your focal point. It's going to hit your mirror. See how that's not exactly right? erase. Okay. So I'm trying to get it. Okay, that's decent. Okay, that's not too bad. And then kind of where these line up, that's where your image is going to be. And so now see if we can get our image to work right. See how this arrow is like way off. Okay, that's a mess. Okay, I'm just going to draw the arrow myself. I'm going to try not to do it myself because I can't draw very straight. So that's going to be our image. So then if we wanted to talk about our image, they'll ask you like, what type of image is it? Is it upright? Is it real? Is it virtual? And so what I said earlier is that this side, the way I kind of think of it is this side is like real life land. Because that's usually where the object is. And this side is like virtual land. Okay, that's no problem. And so this is virtual land. And then if your image is in virtual land, it's a virtual image for these mirrors. For the lenses, it doesn't necessarily work out that way. And so this is going to be a real image. It is going to be smaller, right, than the object. You can see that it's much shorter. And it's going to be inverted. So it's going to, if you were doing the math, it would have a negative height. Okay, and then, so there's our summary. And so now here's our math. And I'm going to try and go through this kind of quickly because it's already 6:50. So a concave mirror has a focal length of 20 centimeters, and an object with a height of 2 centimeters is placed 25 centimeters from the mirror. So calculate DI and HI. So I'm going to do 1 over 20. You know, our formula was, if you remember our formula from earlier, it was 1 over F, 1 over DI plus 1 over, this is supposed to be a D, TO. So I'm going to do 1 over 20, and then I'm going to do 1 over DI plus 1 over 25. Okay, so now I'm going to break this into decimals. I'm going to do 1 divided by 20, and that's 0.05. And I'll have 1 over DI. At least you could see why I didn't want to do lenses and mirrors in the same week, because I knew that would take way too long. Okay, so now I'm going to take 0.04 from both sides. Okay, so then I'm going to have 0.01 1 over DI. So I'm going to multiply DI by both sides. So then I'll get 1 equals DI times 0.01. And then I'll have DI equals 1 divided by 0.01. Which is 100. Okay, now that I've got that, then I can use my HI over HO equals DI over DO, because I've got everything now but HO or HI. So I'm going to have HI and our HO was 2. Our DI was 100. Excuse me, I'm so sorry. Over 25. So now we can do that cross multiply. So I can do like 25 HI equals 200. And then I can do 25 over 25, or 25 over 200. Is that like 8? Okay, so there's our HI, 8 centimeters. Okay, now convex mirrors, the good thing about them is they're only one type of drawing to do. And so I know we're kind of running short on time. So for a convex mirror, we already know what all of these things are called. This is kind of what they look like. Okay, so your mirror is going to be like your mirrored surface is right here. Okay, so it's reflecting. They just have these on this side because it's curved that way. Okay, so anywhere on a convex mirror is gonna the diagram is gonna look exactly the same. So let me do the diagram for you. So so sorry. We're still gonna start with our parallel. Okay, and then we're gonna go through. Okay, that didn't work. Maybe I'll start on this side. Maybe I'll try and draw it. Can I get the ink to be green? Okay. So it's not going to be exactly the same green. So we're going to go through here. See, I'm not really great at straight lines, but you kind of get the idea. Okay, and then I can at least do the center of curvature one, hopefully straight. So then we're going to go through the center of curvature like that. And then we're going to make one more, that last one that goes angled. And it's like it would go through here. Okay, but it's actually going to go it's actually going to go parallel like this. Okay, and then where excuse me, where all 3 of these meet, that's going to be your image. So let's see, if this had been straight, it would have been like right here. Oh my gosh, that's a huge arrow. I'm not going to do that. I'll just draw my arrow by hand. Okay, that's kind of where they would have met. Okay, so you're going to have a smaller image. Oh, it's going to be smaller. It's going to be upright. And then, let's see, I want to make sure I get it right. Yeah. And then it's going to be virtual. Okay. Because it's still not where your object is, right? It's on the other side of where your object is. So again, this is like real land, and this is virtual land. Okay. So anywhere on a convex lens, it's going to be smaller, upright, and virtual. It doesn't matter. Okay, and then we've got this math problem. And this math problem is going to go exactly like the other one. I'm going to go ahead and set it up for you. But then we have our faculty meeting at 7, so I'm going to have to go to that. So I'm going to go ahead and set it up. I'm going to put my focal length here and let you guys finish it. And then in the I Spy, I'll put the answers. So this is going to be my object distance, and then my image distance, and I'm going to solve for that. And then I'm going to have HI, which I'm going to solve for. I'm going to have 2 here, and I'm going to have DI, which is what I'm going to find. Your answer from this one is going to go right here, and you're going to have 15. Okay, so I'm going to set these up, or I'm going to solve these, and then I'll put the answers in the I Spy for this section, so then you'll know what they are. So that is our first half of the review for the optics unit.